It goes. It starts.
It starts. Welcome back to V Brown Bag, my friends. Tonight we've got Rawlinson Rivera, who is going to talk to us about virtual volumes. But before that, let's just have a couple of quick notes. We've got V Brown Bags every Thursday and Tuesday and Thursday and Wednesday, depending on which time zone you're in. Follow along using the V Brown Bag hashtag, and I'll answer and relay questions to Rawlinson. But I think that's pretty much it. Are you good to go, Rawlinson?
Yeah.
I do have a little thing that I want to say before to everybody out there before I hand over to you. Do you
Okay.
did you used to, or well, I guess used to now is probably the right way to describe it. Did you watch Top Gear from BBC?
Yeah.
All right. So some say that he taught Captain Visan everything he knows, and that he used to be able to do a misty flip to a fish brain with his eyes closed. All I know, he's called Rawlinson Rivera.
Oh my
Over
God.
to you, my friend.
All right. Thanks. So let's show my screen. Perfect. All right, folks. So I guess thank you for having me. I'm a little late as usual. It's not like it's anything new, but it's how I roll. So today we'll talk about a bit about virtual volumes. Here we have it as a technical overview. Because this is a brown bag, you can be fielding questions and feel free to ask, and we will stop whatever's going on and kind of address them as best as I possibly can. So let's get going here. So the big deal about virtual volumes, obviously, there's some marketing stuff, which I won't really get into. We all know at this point, what this is about: enhancing and making sure that the software-defined data center really works. And the focus is on one of the pillars of the software-defined data center, being storage, and how do we align things much better to work with applications. So one thing that I have to say when it comes to our new technologies that are being delivered by VMware, specifically around software-defined storage, I like to always take a step back and look at it a bit more beyond the actual technology that we're bringing, but more on the impact on the operational efficiencies and integration with the rest of the platform that is being delivered, which for our customers, for me particularly, it makes more sense than just focusing on the dirty, nitty-gritty details of one particular feature, because it's a means to an end, and it's important to look at the overall picture, like what I want to talk about here very quickly, which is what are the challenges and the pain points that we are aiming to address and fix with virtual volumes. So not just virtual volumes, but with the whole software-defined storage strategy, right? So there's no point in wasting a lot of time when explaining what this is here, but I'm sure that everyone can understand as admins and people that have experience dealing with virtualized infrastructures and some of the pain points that we have as it relates to the low levels of utilization, over provisioning, things that we deal with. But two things that are very, very specific here is the way in which we manage and consume storage in the form of silos. That overall has worked for years. It continues to work today. But as what you continue to hear from customers in the demand of applications, scalability, agility, and all of these things, the precious metal sort of approach that we take when we define tiers and classes of service becomes a little bit too static, right? And it lacks granular control, and it also leads to doing things that we don't always necessarily want to do, depending on the different hours of operation and the times in which we can do some of these things, referring to migrating data and all around. Overall, also enabling a much cohesive and better communication between the parties that have to consume, manage, and maintain the infrastructures. A lot of folks tend to think about all the technologies that we're bringing to life now that are becoming tangible, sort of eliminates the storage admins. And I can tell you for a fact is not true. And virtual volumes is another thing that enforces that. It just makes things a bit more efficient, and we can focus on different things around the same messaging. When you think about the whole fact that, with VMware now we're getting into the storage space, customers would ask, why is VMware getting into this storage space, and it's not just getting into it. We've done things before, just not in the level and scale that we're into it now with some of the products that have been released with Virtual SAN and what we're now doing with virtual volumes. The thing is that because of the hypervisor's capability and its unique placement in the stack, we're able to make things a bit more efficient and better in a lot of different ways. You know, it applies to network, compute, as well as storage, and we're able to make things a little better for our customers and things here. Now, one of the things that everyone tends to hear about is this whole, you know, agility and automation and being able to scale really large. And every time I hear that, I cringe, because for someone who has, you know, experience in the enterprise, in the Fortune 100, 500 companies, when I was part of the professional service organization at VMware, you know, people talk about that. Companies really talk about it, and they want it. But the issue is very few of them are mature enough to adhere or be able to consume such a operational model efficiency and be able to deliver that. Which, and again, what it does really is causes chaos, because, you know, you can have all this agility, but when you can't control it, you have a much bigger problem. So when it comes to addressing those things, obviously when you compare today's world, we deal with LUNs and a lot of static configuration and how we define and architect infrastructures around static definition of construct and services that are provided or individual containers or LUNs or volumes, whatever we call them. The focus now is obviously moving things that are focused entirely on the actual application, more on the VM, removing the complexity and some of the operational inefficiencies that exist, and at the same time be able to deliver the whole wanted agility, that automation level, but also with added control, which is what you'll see here in LXL Innovate. So that is the whole focus particularly with the approach for the software-defined storage, you know, the virtual volumes and some of the other technologies that we have, which overall enables all those things that customers are looking for. So with vSphere 6, obviously we're extending our footprint in terms of what we're doing with the software-defined storage strategy. We initially delivered the entire capabilities in a hyper-converged sort of hypervisor converged solution with Virtual SAN. Very unique, very internal to the VMware stack. Now we're expanding to the ecosystem where now every other vendor that's part of this initiative can take advantage of the same services, capabilities, and management of our control plane and our data plane that are delivered through the software-defined storage, right? Which the whole point for that is it's important to understand that virtual volumes is not just about another technology, because there's a lot of things that come into it. We can get into a lot of really good discussions on that. I hope we do that here today. So I always like to kind of level set the whys before we get to the tech. And obviously we have a lot of pain points that this particular solution here is trying to address. And as you can see here, it's more about being operationally efficient and delivering some of these things which are more important than just, you know, why the tech is there. So when we describe virtual volumes is basically a management framework that is allows our external storage to be integrated through the vSphere stack and more effectively take advantage of all of the capabilities that we can deliver, but also deliver their value, because nobody does anything better than the actual storage subsystem, because they know best when things reside on that particular array, on that particular device or system. So it's kind of always better off to do that. In terms of some of the basic, what this accomplishes and what are we doing, it virtualizes SAN and NAS devices. But the big thing here is the big takeaways are we're now making it so that a particular array is able to now understand natively what these so-called VMDK, these virtual machine derivatives, what they are, right? Which are now they're represented in a different form because of the way in which they are sort of consumed and added to the system in the form of objects instead of just particular VMDKs. This sort of integration, this framework enables enables VM granular provision capabilities, which are focused specifically on a per item, on a per object basis. And the focus is to leverage and improve the control and management of the virtual machines and the applications themselves through a policy framework that is native to the vSphere stack, right? Something that is part of the vSphere framework and you can leverage that. Now, this is a new storage sort of shift, a new storage sort of solution, you can say, but it's still not designed to to change everything, to disrupt everything in the way that, we're not introducing proprietary protocols or things like that to use virtual volumes. We can still leverage the same in all of the existing I/O protocols that are in the market today. One of them you can see that it's clearly missing there for the Fiber Channel over Ethernet, some of the things that are out there. And this is not a VMware sort of solution only. We obviously we created the framework, but this is an industry-wide initiative that is supported by all the major storage vendors that exist today, and you don't have to pay for it because, well, I don't know if you don't have to pay for it. I don't, but for the most part, it's part of vSphere and some of the different licensing that are available. So to look at the overall architecture, there's a lot of different pieces here, and obviously the focus is this product is called, or this framework is focused around virtual volumes. What are virtual volumes? Are the actual objects and components that make up a virtual machine now as they reside on an array. So we'll cover some definitions on that. And then beyond that, there are other construct and components that are very important to how this framework works, which is composed of virtual data stores and how they map to a storage container. We'll also talk about the protocol endpoint, which is the medium on how things get communicated. We'll get into more details of that. There's this vendor, also known as a VASA provider, which is the device or the component that communicates between the storage system and the actual vSphere infrastructure to get and validate all the different things that are happening within the systems. And then on top of that, we deal with policies and capabilities, right? But let's get right into the what I think is one of the one thing that's really important to kind of get out of the way, so that way hopefully questions will start flying fairly quickly. So when you describe virtual volumes, they're basically objects, right? So if you're familiar with virtual SAN, this is very similar to that concept where we're dealing with object store type of solutions where now your storage system, your array systems have become object storage in the sense that, these components that we know today as virtual machines will now be natively stored in an array in the form of an object. What does that mean? There's no file system that needs to be added onto that particular storage array in order for it to understand and manage our virtual machine components and objects, or VMDKs per se, right? So the big thing here is that there is no file system in place. There is no VMFS needed or required, and that is a plus when you get into that world because we understand that as we add more layers of abstraction and more layers of components and things, there's some implication that comes with that. And in this case, we're actually talking about, there might be limitation in performance, limitation on capabilities, and limitation on things that can be done in a particular file system, which right now we're basically eliminating that. When you think about the different types of virtual volumes that exist, compared to very similarly to what virtual SAN delivers, so we have 5 different or unique recognized virtual volumes which make up a virtual machine. And if you know anything about virtual SAN, you can see how this is kind of very consistent in that sense, but they have different names and terminology. So obviously now, when you look at, there's a config vvol, which is, it makes up and stores all of the different components of a VM when it comes to the logs, the VMX file, VRAM, log, etc. Those things. The VMDKs are referenced as a data vvol. The snapshots are memory. There's a swap file, and then there's another. The other vvol is vendor. It says here vendor specific, but let me correct that right there because it's not really vendor specific. When I say vendor specific, I mean vSphere specific, because this particular virtual volume appears when you're using technologies within vSphere that comes from other products, such as CVRC, which is the internal, the code name for what's the name of that product? The View Storage Accelerator. That's one, right? So there's a file that gets created, and that becomes another vvol because it's not the default type of vvol that appears on every virtual machine. And there's some other things that you find it there. The big thing that you understand here is this: in vSphere, as a vSphere admin, you will always see the same thing you've been seeing for as long as you've been dealing with VMware, which is VMX files, VMDK files, vSwap, and all that stuff as you see it there. A storage admin will see these virtual volumes on the array, right? That's what they map individually to that case. So it's important to understand that as a vSphere admin, that doesn't change. But now the conversation between the vSphere admin and the storage admin can be delivered a little bit more efficiently and better because now you can map each one of those different types of objects or VMDKs to a particular object on the storage array, which can be used to monitor it, configure it, and do things that may need to be done at that level. So far so good. I think I haven't heard any interruptions.
We've got one question. I got one question for you, just to interrupt before you go into storage containers. On the GoToMeeting chat, there's a question from Double Density. Says, do vVols use OSFS UUIDs for objects like vSAN does?
Mm-hmm. Wow, that is a good question. No. The UUIDs for virtual volumes are based on an I forgot the standard which what manages this, the ID and how it's identified. But if you give me a little bit as we start chatting, I'll kind of dig it up real quick on my system. But it's not the same type of UUID.
No problem. Keep going, and that we can get into the nitty-gritty later.
Yeah, cool. So we're going to identify a couple of new concepts and constructs that are now introduced with virtual volumes, right? So one of the things that you'll find is the concept of a storage container. And to just be quickly about the stuff and kind of the overview, so we can get into the nitty-gritty, a storage container is no more than a logical construct that is identified at the storage array level, which is utilized by a storage admin to define capacity to allocate capacity in some level of restriction, a management construct, but also at the same time allocate and enable certain capabilities that are available on the array to a particular container. And we can get into the details of the implementation, how that works, because it doesn't work the same for everybody. And that's some of the really valuable stuff here. But the whole point is this. A storage container is basically utilized to store virtual volumes and control management by providing allocation for capacity and different capabilities that may be available to the vSphere from the storage array that can then be consumed by the vSphere admins. There's a minimum requirement when it comes to these configurations that are very minimal. It's one. Maybe not all storage vendors can support more than one. Some of them actually do only support one today. As they evolve to that, to different solutions depending on what their architecture and their current array solutions are delivered. And again, it basically depends on them because this is not something that we entirely control, but it's more of a what's delivered by the actual vendors themselves. So one question that you'll find: so a storage container, is it the same or is it equals to a data store? And in a way, it kind of is. So when the question comes up, do we still need to create data store? So, well, a data store is something that exists in vSphere. And if you think about it, all the knowledge that you have about VMware and vSphere, every single product, every technology that we have is dependent on one particular construct, a virtual data store, a vSphere data store. When you think about HA and all the things that we have, it's heavily dependent on that. And therefore, in the vSphere world, we will always have a virtual data store, a vSphere data store. The thing is that particularly maps to a storage container on a one-to-one basis to a particular storage array subsystem. So are they equal? In a way, in some sort of a relative fashion. But the important thing to know is this: a storage container is managed like and handled like a LUN, but with additional goodies because it has all these different capabilities that it can be leveraged and assigned to it from the actual array subsystem, which is pretty nice. But logically, it's kind of very similar in that sense. So here's some of the things that differentiate a storage container from a particular LUN. And then we can talk about how this new implementation helps us get beyond some of the limitations that exist within vSphere today as a product in regards to the limit of LUNs or data source that can be mapped to a particular host, right? Which we know there's a number of 255 in that case. And we'll get into some of that stuff in more details here in a little bit. So from a workload perspective of managing and what's done in capability, take a look at how this workflow showcases clearly that while things are a lot easier for the vSphere admin, there's obviously a place for the storage admin as well, because the storage admin still controls and have access to a particular area in its domain. Here, in this case, obviously the storage admin is able to define and create storage containers, which can then be consumed by a vSphere admin through the different interfaces they have and map them individually to a virtual data store, right? So we actually have to have that model in place. That's how things kind of get mapped together. Now, obviously, depending on the implementation of the vendors, they could actually embed this whole thing, which some of them already do have that, where actually the vSphere admin can do all of the tasks that are almost needed that are performed by the storage admin from the vSphere web plugin. So here's an example of what happens when you try to map a virtual data store to a storage container. This is the same menu we've seen all along, but when you look at it here, when you look at some of the definitions, you see that there's this unique identifier for the virtual volume container that I'm trying to map here. But essentially, you're mapping a virtual data store, which when you go through the wizard in vSphere 6, you'll have three options. You'll have NFS, VMFS, and virtual volumes, VVOLs, right? And when you choose that, the system will actually know what to do. But again, you're still mapping that logical vSphere construct to another logical construct within the storage array, and it's that one-to-one relationship. Now, when you look at and identify and you browse the virtual machine files, what makes up a virtual machine files, for those of you that are vSphere admins, this is very familiar to us, right? It's the same thing we've seen forever, whether it's the web client or the thick client, which still works these days. But when you ask a storage admin to look at the same information from a virtual machine, but on their particular system, on their management interface, it's represented a little bit different. And here is a really good example of that. And to be honest, this is probably my favorite UI when it comes to representing a virtual volume construct from a storage vendor so far. And I don't mean to be biased. I'm not biased. Everybody does some really cool things. But this is the one implementation that allows us all to see things the way we kind of need to see it when something is introduced new, such as this. So, for example, if you look here on the right, the Dell implementation for this on their EqualLogic Group Manager, you can clearly see here that when you select a virtual machine, below it, it identifies the virtual volumes as they are in vSphere, but also as they're represented in their types on the storage system, which is what I presented before: config, data, swap, memory. That is very useful because now the storage admin can actually monitor, do performance trending and analysis on these objects and knowing exactly what they're doing. And not every implementation has this. Obviously, remember that can change over time within a patch. Different vendors can do different things, but so far this kind of makes it a lot easier to sort of consume and kind of understand the new concepts that are being delivered here and how the two different parties will be able to identify the virtual machine objects as they are within the different interfaces. Any questions on that?
I got nothing. Everybody's good with that. I have one. Can you just flick back to that previous? In that storage admin view, you've selected the engineering Tomcat server, and it's got the different vVols that are there. Mm-hmm. If you applied one policy to, just say that had two data vVols, so you've got two VMDK files, mm-hmm. Would it actually come up and split that between different storage containers and show that within that view that multiple storage containers were part of that VM? And then I'm assuming those storage containers, you would need to have both storage containers as data stores effectively within the vSphere view, and you would see folders within each data store just the same as what you would if you were splitting VMDKs over traditional data stores. Is that right?
Excellent question, and hopefully people kind of get in, follow your lead and continue to do this because this is really good. So it depends. Number one, so if you think about a storage container, in a storage container, the way in which we manage the capabilities of the array, the way the part of the reason why this is introduced is so that we can mitigate doing such things, Nick. So, for example, a storage container should be able to offer and give you multiple capabilities. in which you can assign multiple and different policies to individual VMDKs, which means if I have two VMDKs here, maybe I want one VMDK to be on X type of service, on X type of race set level, on X type of data service capability, and another one the same, but that could coexist within the same container. Does that make sense?
Yeah, that makes sense.
So on the array, remember, a storage container basically controls and allocates capacity, but it also gives you the ability within that capacity to consume its capabilities. If that particular container has been configured and is enabled to deliver multiple capabilities, which in our world becomes, it's consumed in the form of a policy, multiple VMDKs can still exist within the same container and still have different types of policies, because individually they're being given a different capability by a different policy based on the capabilities of the array. So we don't have to have, for example, the splitting behavior where I have to have them on a different storage container or virtual data store per se.
So what you're saying is that the policy is on the virtual volume, not on the storage container.
The capability is enabled on the storage container. The policy is applied on the virtual volume.
Got it. I have a question from Derek. He's saying,
sense?
Yeah, it does. Derek's asking how many storage containers, and he's mentioned here on an EqualLogix array, but let's say on any vendor's array. What's the limitations on how many storage containers they can have?
So that's a question that is pretty hard to answer, because I can tell you there's some that have one and that will only support one, and some that will support multiple. So it's not a limit per se on the framework. It's a limit, or not even a limit. It's based on the architecture of the array that you own.
It's an implementation detail on the array vendor.
Correct. So that is based on the architecture of the storage vendor, right? And you can think about it like this. Some storage vendors can present one entire device as one single unit of storage, or you can consume it by carving up little smaller volumes or LUNs and things, right? When that's the case, they should be able to implement and deliver multiple storage containers, whereas some others don't, where the concept is just to simplify everything and just give you one, which again, that's one of the goals of this framework, which is to reduce the use and the management of LUN. We want to get out of the LUN management business and make things a bit more efficient.
So does that mean that we're not limited to a size for the container? I think we already covered this, but that means that the storage container can be as big as a whole array then?
Absolutely. So there are no limits here in terms of the capacity and the allocation on a storage container. Again, that is the design intent. This is basically driven by the actual storage vendor in the implementation. But yes, we talk about this, and I've actually been one of the ones professing this approach, which in some cases it works and some others it doesn't, where you can have an entire array presented as a single storage container and presented to vSphere, and we consume it, and that's it. There's no moving. We're concerned and worry about moving things around to get whatever. The thing is that within that array, typically we tend to build multiple LUNs. These different LUNs are configured with different rate sets. Different capabilities are assigned to each LUN or mount point, and then we manage things in that same way. Now think about it like this. We can now do it in one container, one data store, and still be able to do the things we did in the past, just not in the way that we did before, where we had to move things around, where we had to manage and maintain separate constructs to achieve what we want. Now we can all do it on the same one, which reduces the complexity of the environment, reduces the risks, but still able to deliver the same level of services, but also maybe potentially even better, because there are things that are offloaded directly to the array, and we don't have to manage them from the vSphere stack perspective.
Okay, great. I've got a couple of questions here before we move on. One is, what's the largest out in the field? Graham's asking, what's the largest out in the field? I'm assuming what's the largest kind of capable array. Can you just give an overview? I know largest is subjective, right? But can you give me an idea or give us an idea on how many different arrays have been certified, how many have had their VASA 2 firmware update out there, what's actually out there available today.
Who is this? Is this Grant Orcher asking that question?
No, Graham Mitchell.
Nick, was it Grant Orcher asking that question?
No, it was Graham Mitchell.
Who I love. Oh, I'm sorry. I thought it was Grant, my buddy Grant, because I was about to give him some grief. So okay, so in terms of what's the largest, I can tell you what I've done in terms of the largest, because I don't know externally what people have been using. So I can tell you that I've done beyond the normal. I've done a 20 terabyte storage container. I've done single. I've done multiple. And I've used it for many things, right? In reference to the vendors that are out there, I can tell you that so far, I've touched a NetApp, obviously Dell, Hitachi, which is obviously has one of very interesting implementation. It has some really cool stuff. I've touched what's the other one? I have a couple, but I think I've seen it and touched most of them. But I can tell you who's going to be on board from the very beginning: IBM, NetApp, Dell, Hitachi, Tintri, Nimble, Atlantis, NextGen,
EMC.
Obviously, I was going to say that. Obviously, EMC, but
SolidFire.
SolidFire, Pure. So this is something that everyone's doing. The thing is that not everyone made it GA. Not everyone made GA when we GA the solution, right? And obviously it's because they're still working on improving their implementation. Because this is something that's it's a capability within vSphere, but it's something that is very personal to the actual vendors because it's how they deliver their value. It's how they differentiate themselves between the different storage vendors. It's very personal to them, right? When you think about storage, in some way, shape, or form, storage is storage, and at some point, everybody's going to do the same thing. But in terms of features and capabilities, but always there's some sort of magic, or some sort of value add that is exposed by the different vendors, and I think that's what they're focusing on and exposing value to customers. So some of them have taken a bit of time to get there, but everyone's going to be there. I can tell you that all the major players and all the major vendors, and even not only the more, I don't want to say the more established because everyone's pretty much in the mix, but the bigger companies, are definitely on, and so are the newer up and coming sort of companies like the SolidFire, Pure, Tintri, Nimble. All those guys are doing that and supporting the project here.
All right, a couple more questions. They're coming in thick and fast at the moment. How do PEs, protocol endpoints, tie into storage containers?
I'll hold that question once I hit the protocol endpoint.
Sure.
Comment.
All right.
Hold that there.
Yep, we'll hold that one. And the other one is the auto-tiering concept, the array-based auto-tiering concept, part of virtual volumes? Or is it done at the container level, and how does that tie into things?
So it's done at the container level, and it's done based on the implementation of your vendor. I can tell you that EMC is going to do that. I hope I didn't get in trouble with that. But obviously we all know that folks. FAST is a well-known and really good used feature on EMC arrays. And that's one of the things that EMC is going to deliver as part of their implementation of virtual volumes, which is, on their arrays that support FAST, those are the sort of things that will be there. But when you think about some of the other vendors and how they achieve some certain things, there could be some movement around depending on how it's done, and obviously some intricate implementations on how that works. But that's the way that would work, right? So we want to have the auto tiering thing is, when we think about auto tiering, we have to manage multiple containers, and today there's some features that work with vSphere Virtual Volumes 1, the initial implementation in 6.0. And some others don't. They're native in vSphere, which lets us do what we do in terms of managing tiers and things like that, like storage I/O control and all those kind of things. So some of those things are not there yet, But depending on how the array implements some of these things, they'll be able to do that. They'll be able to obviously leverage the smarts that they deliver on the array level.
Cool. All right, there are a couple of questions, but I'm going to hold
Any
off
more?
to let you go on.
Bring them. This is what it's about. Questions are better than slides.
All right. So our friend Emad has asked, how do vvols compare to other containers like Docker?
Oh, that is a very different thing. So vvols is specifically, when you think about it, is an encapsulation of the components of a virtual machine in an object sort of aspect. When you think about Docker, and I'm not going to claim that I'm a complete expert in Docker, it's a different level of abstraction which is applied at the application level, right? So it allows you to add that sort of abstraction on a per app, intricacy things that are at the actual application level in the sense of the internals of an application, right? Some of the things that we experience with, a quick example, dealing with system IDs and things like that, when reinstalling application, being able to take an application completely out of it and put it somewhere else. So it's a different concept when it comes into that, but in a way, logically similar to what's being achieved on the storage side. This is being achieved on a more of an application side, which is what Docker delivers. And if I'm wrong, anyone can please feel free to school me and smack me down on that.
I'm not going to go into Docker at the moment, but yeah, they are very different technologies. I got one from Double Density, which is a great question. Do vvols change the data path to the array at all? Any new options or considerations for the network level or setup? I'm assuming he's talking about the pathing network.
Yeah, absolutely. And is that the last one? Because that's the very next topic we're getting into here.
Yeah, that's fine.
Was that the last question of that round?
Yep, that's the last question of that round.
Okay, so when it comes to data path, obviously it's a little different. You can see some of the stuff here. So what enables and allows that sort of configuration, how it works, is through what we now call a protocol endpoint. And I hope I have the slide here, which it sort of helps me explain some of the whys as to why this is happening beyond just the sometimes marketing jargon that we do, but whatever. I'll explain it even if the slide is not here. So here's the thing about what we call protocol endpoints, some also known as, referred to as it's a PE. This is the actual component that enables the communication that takes place between our vSphere stack, particularly the ESX host and the storage arrays. Traditionally, when you think about where this comes from, we're not really introducing. This is not an entirely new concept. We're actually decoupling two things here. Number one, the protocol endpoint is part of the source fabric given. Typically, this is something that is created and performed by a storage administrator. But the thing is that when you think about where the protocol endpoint sits today, if we didn't have virtual volumes, think about it like this. A protocol endpoint and a data store are together, are the same thing. Because today, when we configure communication and pathing to a particular LUN, goes to that LUN ID to that particular LUN. But also, we tend to store on that particular, for lack of a better term, container or construct or object to store VMs and VMDKs, right? Which is where the issue that we hit today with our 255 device mapping limit, right? And I'm going to show you how by decoupling that, we're able to go beyond that for some reasons, and I'll explain why. But also, it's what enables, what enables the whole communication and the data path between the container, the virtual volumes, and also vSphere. Now, when it comes to the actual supported protocols, they're the same ones as I said before, and you can support any protocol endpoint can support any one at any given time, which means you can have multiple of those, right? So many to one. And the same multi-pathing policies capabilities that we have still apply and are applicable today, whether they're NFS topologies, obviously, or any of the block-based implementations, but either way, they are going to be applied onto a protocol endpoint. So, for example, if you want to look at, traditional, we go look at a LUN and we look at multipathing, we look at the LUN properties and we find out information. What happens now is when you're going to look for the same kind of information, you're not going to go directly to the LUN ID or to the virtual data store. You're going to basically look at the actual protocol endpoint. The storage admin adds the multipathing capabilities to the protocol endpoint on the array side, and then by the time you actually map the particular virtual data store to that storage container, all that stuff is already configured the way it needs to be done by the storage admin, right? Or by yourself if you happen to play multiple hats. So the question comes a lot of times, why do we need a protocol endpoint? Here's a slide that I thought I didn't have, which is perfect. And this is what we've done and what problem this solves, if you think about it, which I basically explain it, right? So today, because the data stored in the protocol endpoint are part of the storage fabric, they're one. That's what actually gives us and presents that limitation. So how do we get around it, right? How is it that by now being able to have different protocol endpoints to the different in different data stores, the PEs no longer become a constraint in terms of where the VNDKs are, but basically it's nothing more than an access point, right, on how you're going to get to that particular virtual volume. So here's what happens. So today, when you map a data store to vSphere, a traditional LUN, it's in this way, where the PE and the actual container are one. That LUN is one. With virtual volumes, you can have a PE and a storage container, and now they're now being completely separated, where how this works is helps us bypass that limit in a way that exists between the 255 devices mapped to vSphere per host. Because in this approach, here's the concept. When we do multiple LUNs in vSphere, we do it because, number one, we need to have either more capacity, we provide different service levels, capabilities, and all of those different things that we manage individually per LUNs, right? Each one of those LUNs has its protocol endpoint defined of what it is by the source system. Today, with virtual volumes, you will be able to basically define less or least number of storage containers, and potentially, depending on the vendor implementation, have a larger number of protocol endpoints, which is basically the access point and what enables communication between the container and the particular virtual volume that exists.
So does that mean that it could be different protocols? So you could have an iSCSI and a Fiber Channel protocol endpoint at the same time to the same array?
Absolutely. Absolutely. And the beauty here is this. So now, and this is sometimes a hard concept to grasp with people, because obviously with everything being new and some new concepts being introduced. So because you can have a storage container allocate a pretty decent and large amount of capacity on an array to do many things. Now what you need to worry about is basically how many protocol endpoints do I need to have to that particular storage container in the actual number of virtual volumes that I'm accessing to deliver the performance I expect, the right queuing, and all that stuff, which is a pretty hot topic that Duncan and I have been discussing. He's been beating me up pretty hard on it because there's some things that we need to call out specifically on when it comes to performance and the whole queuing on how we manage things, right? So obviously having multiple protocol endpoints leads to high availability, different protocol access, like you just mentioned, Nick. But when you think about it, this enables something that now you can have really large containers, but manage them in the least quantities instead of having the same number of LUNs that we manage today, right? And that's how we get around that particular limitation in vSphere from many angles, from a capacity recoverability perspective, and all those different values that are there. But understand that if you choose to manage this in a different way, where if you still choose to adopt the traditional model where I need to have a storage container per X, right? And you start using this as a LUN per se, where you start having multiple containers and treat them as if they were traditional LUNs, you will hit the same limit, right? because the limit exists based on vSphere devices. And a virtual data store maps specifically on a one-to-one basis to a storage container, right? So understand that the storage container, because it sits on the array, there's no VMFS. It bypasses all of the sort of constraints and things that we are concerned with when it comes to having multiple LUNs, the number of VMs we put in them, having to recover them, having to do all the things that we need to do to them, snapshots, and all different services that are available. And I just hope that sort of concept really sticks with people, because this is what's important. It's not just, so here we have a piece of technology that wasn't really introduced new, but we kind of actually split it to deliver a better overall service and capabilities to the overall platform in a way which is more effective, and it lets us kind of get over one of the limitations we have in the platform, period, when it comes to that.
Yeah, makes sense. So Graham's also just followed on with that question around can you have multiple protocol endpoints for the same? He said, so does that mean that there's one protocol endpoint per VM since the PEs are piped down to the storage?
Not necessarily. So I can tell you based on implementations from the vendors, and again, keep in mind that we'll cover everything that we can in terms of the framework, and I'll tell you everything I possibly know based on my experience, and I have experience with a lot of different devices. But different vendors have different implementations down to the PEs themselves. I can tell you one example here where, and they're GA, so I can actually openly speak about this. So one example of that is when you say one PE per virtual volume, it doesn't really work that way because you don't really need to in some sense. So here, look at it like this. If you are using, for example, an XIV, which is IBM's storage systems, they support virtual volumes out of the gate. And XIV works as a grid system, which basically one of the things that it does, particularly to virtual volumes, is that whenever you add a host to a cluster and it becomes whenever you add a host to the system and it's part of virtual volumes, it automatically creates another protocol endpoint on the host level. So each host delivers one. And that could be configured to multiple. I just don't know the actual details on it. I haven't had the opportunity to dive too deep into those details per se there. But some other implementations allow you to have multiple PEs, but also some others allow you only to have one per container, right? And those are the things that you have to start kind of digging for your particular vendors so that you could understand exactly how you're going to manage and how is everything going to perform based on the implementation they've chosen to do, right? So a vendor can tell you that X number of PE based on the number of virtual volumes that are being accessed through X number of containers. But that's something that comes directly from the particular vendors and their implementation, because they've actually designed it to be in such a way and curated to be in such a way. So keep in mind this. The virtual volumes framework is designed to support millions of objects within a container or within an array system. Now, the number of volumes that are supported on a particular platform is entirely dependent on the vendor, right? And I can tell you that today I have not heard of a single vendor that's working within the millions of objects yet, right? I could be totally off mark here, but I haven't heard from any of them yet within the millions. Some in the thousands, obviously, in the hundreds of thousands, which is where we want it to be, because if you think about it, that becomes really, really important, because the number of virtual volumes that are going to be created depends on how you configure your virtual machines. So I can tell you that the default number of virtual volumes that are created on a very vanilla plain virtual machine with a single VMDK is 3. Every time you create a VM, you're going to get a config vvol, which is all the directly the file of what we know. You're going to get the VMDK, which is the data vvol, and once you turn it on, you're going to get your swap vvol. If you had multiple disks, if you had snapshots, if you had other things, that continues to grow, right? And that goes against what the array supports, and that ties into all the requirements and queue and performance and monitoring what the vendors have done for the implementation of their protocol endpoint, and leads to whether we could do that with one, we'll need two, container, and whatnot, because those are the things that actually make a difference in identifying when you're going to look into one of these things for your particular vendor implementation.
Yeah, so that's a question. The follow-on from Graham is, if I had an SQL server with 20 disks and 20 LUNs, to get the performance that I need, would I want a single PE or 20? So I'm guessing that depends on the array, right?
Correct. Graham, that depends, but that is an excellent question, because I think I'm going to guess that I know what you're thinking, which you're thinking into the whole queuing aspect of that, right? You don't want to saturate and have things not working the right way. So again, these are the kind of things that a particular array implementation can give you, and that is a great question to ask. But understand that one thing you brought up here is this, and it's something that is not unique to virtual volumes, but it's something that is coming, and we need to adopt and kind of sort of let go of our affinity to the concept of managing multiple LUNs to deliver multiple things and capabilities. Because in one case, you're right? Because a different LUN gives you, as I said before, its own PE and its own storage container in one. Those things happen, and we have those capabilities there. But that goes through our stack. Now, we're touching that, so there's a level that we're touching. So with the new software-defined storage strategies, one of the things we're getting rid of is having to deal with managing multiple LUNs, and that's where we split things up. So being able to achieve what you want with, per se, a SQL server with 20 different disks can be achieved within a single storage container, and you don't have to have them spread through 20 different virtual data source, which again essentially obviously map to a storage container. And that is a performance factor that you get out of, you'll be able to evaluate from the vendor implementation, because now you can have guarantees on each one of those disks. I would presume you have your logs, different database drives have different requirements, and you should be able to assign and configure what they need from a storage perspective individually per object while residing in the same container. Because one thing that doesn't exist today out of the box today is one of the things that you actually asked about before, Nick, which is the ability to moving things around, moving VMDKs or objects or vVols around to sit in different containers automatically, right? So you have the ability of initial placement, that's all vSphere related stuff, and it'll map. But whenever you map capabilities and policies to a particular virtual volume, the framework now will look at compliance. But when something is not in compliance, it'll basically tell you, you are out of compliance. You need to do something about this. We're not going to automatically do things where like, oh, that's not in compliance, but the other storage container virtual volume is, let me move things over there. That doesn't happen on the vSphere side. That doesn't happen on the implementation side. But depending on the implementation of the vendor, they could do some things, right? Which, that's how they introduce their value add, and that's where you actually have to kind of look into some of those details. And that is an excellent question to bring up too, because it's very important. I find that a lot of folks are kind of bringing that up, and it's because now the concepts of doing different LUNs and different things for different disks and VMDKs kind of goes away, right? So that's not the way to do that when you introduce something like this. Not that you have to, but you just don't need to go the old route, right? You can now try to evolve with the way that the new operational models work with this new implementation.
Yeah, that's one thing that I was thinking. The VCDX defenses for whoever's going to try and defend against vVols are going to be hugely interesting. I want to hear the war stories of those.
I want to be in all the panels.
Yeah, I want to be. There's an interesting question from Samir here. Data store heartbeating for HA now just points at the PEs. So does that mean we'll need at least 2 protocol endpoints?
Man, that is an excellent question there, and you got me there. I have not thought about that.
Yeah, neither have I. That's a great, and I replied and said, great question I'll ask, because I don't know the answer to that.
Yeah, I don't myself. I'm sorry. I'm a total loser. But I will
I'm
know
going to
tomorrow
test.
morning.
I was
I'll
going to
tell you
say
that.
I'm going to test it tomorrow morning.
Yeah, yeah.
All
You
right,
better believe it.
I got another question here. So if you move a vvol between an array and say a vsan, how does
Hmm.
that transfer work?
It's it works amazingly well. So if you guys haven't seen the phenomenon that I unleashed on the world last year called Project Magic, it's basically that. I tried to showcase to the world the coexistence and cohesiveness of the platform using everything that's available in terms of a storage resource to vSphere, moving things between vSAN, virtual volumes, NFS, and BMFS, and whatever else is out there. It's seamless. There's nothing, right? It just works. The only thing that'll be different is that obviously the policies are applied based on a vendor provider, which we haven't gotten to the VASA provider piece, but when you create and you define policies, you define them based on a particular vendor. So obviously, if you're going to move a VMDK from virtual volumes to vSAN, through the wizard, you'll see you want to change the policy. And if you say yes, you change it. It'll tell you, yeah, that's the one that's compliant or not. If you don't choose one, it'll tell you this is not compliant. And depending on the implementation, in some cases, it could fail the operation because it can't satisfy the requirements you want in a particular policy, or it will let you move it. But what will happen is that you'll see that once the object is moved, when you look at the vSphere client, it'll tell you out of compliance because the policies that you have added there are not being applied. Now, if you do not add any policy per se, you say use default or select a default from the policy field. Understand that today vSAN 6.0 and virtual volumes, each one of them have a default policy that can be manually defined on vSAN by the user or the platform itself, and on virtual volumes it's defined by the array vendor. So what does that mean for virtual volumes? So by default, there is a policy in vSphere that says virtual volume default policy, but that maps to something within the array which was implemented by the vendor via the VASA provider, right? So it could adhere to one of those once it sits on the array if you leave it as default, but it will get something, right? But from the sense of transforming things and changing things, it's an object, right? Our thing within the object, still BMFS exists within the object, and that's why things work so nicely as they do today.
All right, and one last question before we move on. We've got one there. So can we create RDMs within a vvol array, or do we still need to present a LUN and do it the old-fashioned way?
We have to do it the old-fashioned way. So if this is getting to can we use virtual volumes as a replacement for Microsoft clustering services per se? From the traditional old school Microsoft clustering services, the Quorum and all that stuff, yes. In virtual volumes today, we still don't do SCSI 3 level low-level reservations, right? So that's something that I don't want to get out of hand here, and Nick, you'd probably be able to say something about that better than me, but I don't think I don't know.
I'm
Right?
not.
So
I'm not
I don't
going
know where
there.
that sits in the stack of priorities.
I'm not going there.
Yeah, so I don't know where that sits in the stack of priorities, but we're just not doing it right now, right? So virtual volumes is not a replacement for that. If you want to continue to use some of these older clustering failover services from Microsoft implementation, you will still have to use RDMs. But some of the newer types of applications support different types of failover clustering, such as file witness shares over SMB3 and things like that. Will kind of let you get over that. But again, that's not there yet. So yeah, we still have to use RDMs.
Cool. That's all the questions we have right now. So let's move on to your next slide.
Perfect. So here's a bit of explanation on the discovery process, because obviously when we talk about how we identify these containers and we map them to data source. So obviously, depending on the implementation in what type of array you may have, the process to discover a container, it's basically done the same way in which we map a LUN in vSphere. So obviously, the storage admin sets up the container and configures what it needs or what is required by the vSphere admin from a capacity standpoint. as well as the capabilities that it needs to add. So think about it like this. We always have these arguments with, oh, the storage admins are not going to be, they're kind of taking their work. We're not really. We're kind of making life really good for those guys right now, because think about a storage admin who manages a large infrastructure, and the way in the virtualization space we consume storage capacity and things we have to do, it's tedious. It's a nightmare. So now you have a storage admin that has the ability that instead of creating multiple loans to do different things, such as deliver some particular data service, which I apologize for the data servers in question on their replication, because we have some stuff to talk about that. But let's say, for example, they want snapshots and encryption or something like that that's delivered by an array system. So they have to always continue to make different LUNs, different of a particular type, presenting a lot of work. There's a lot of risks involved in there. So think about it like this. Now the storage admin can give you a storage container, apply the desired capabilities that a vSphere admin needs, right, which securely deliver its services, and sort of like hand it off, right? And now with the VASA provider, we have the ability to now discover the container and report it to vSphere. So now one of the things that's different between VASA 2.0 and 1.0, for those of you that are familiar with that, VASA 1.0 was an implementation that had a one-way communication, which was based from the array up to our stack, right? This is what I have from a storage perspective. We were able to do some things and define storage-based profiles or something. Whatever that feature was called back in the day, which I totally forgot. But now VASA 2.0 is two-way communication, which not only is the array going to tell me what it has, but then the vSphere framework will tell you what its objects need to consume, right? And basically, this reporting goes through the VASA provider, whether it's external or internal. We'll get into that in a minute. But either way, all the VMs get their they're subsequently provisioned on the particular storage array, and these are commands. These are API calls that are being just passed through that provider and executed down at the array level, where now the array would place those objects where they need to be according to the policy and the requests that are there. That leads to sort of questions around the management plane and how this really impacts everything that we do. So when you look at the bigger picture here, now that we've discussed a couple of components, there's one item that I briefly touched on, which obviously we'll get into more details here, which is the VASA provider, also known as the VP. And again, we go back and forth and calling this thing like 10 different names, but it's officially a vendor provider, right, which comes from the vendor, entirely created by the storage vendor. VMware has nothing to do with this, but we call it a VASA provider because this, that's what the APIs calls it going through. This is what actually connects vCenter, ESX, and communicates down to the array. Now, this is what actually delivers the awareness of services to our stack, right? There's not statically defined. They're dynamically defined at the array level, and they come up to our stack depending on where they're being allocated, whether it's a single storage container or multiple storage container, whichever have you. Now, one VASA provider can manage multiple arrays, which is great. You don't have to have many of those for different things. They come in a couple of different flavors. They could be implemented in the form of a virtual machine, an appliance, or they could be implemented as part of the array. In a lot of cases, if you ask me, they're both great because we obviously provide coverage on a lot of different things, but when things come on the actual array, whenever a vendor is able to deliver that because it fits their architecture better, then great. You have one less thing to depend on and worry about in terms of dealing with it, because the vendor provider is critical. It is extremely critical because it is what's responsible for actually creating, deleting, and doing anything to do with virtual volumes. Because the control path for these actions are what we call out of band, because they don't go through our stack. They're completely out of band here. So that communication happens, and it needs to be available in order for things to happen whenever they're going to be new. So one of the things that I've kind of come across several times when discussing virtual volumes, and as every one of you guys are probably wondering, I'm sure we all think the same similarly when it comes to this. What happens if my implementation uses a vendor provider that comes in the form of an appliance? What happens if that appliance is down. Oh, I can't use my my infrastructure. Now I have a single point of failure. That's not the case, right? So understand that the VASA provider does initiate all the different calls from vSphere down to the array and back and vice versa. But once these calls and these binding operations have taken place, they remain, unless some other things happen to remove them. So in the sense of a vendor provider not being online for whatever reason, whatever's been bound and active and working, VMs that are running per se, will continue to run. But if you try to deploy a new virtual machine, it won't work because now I can't send that communication down to the array. And I hope that makes sense and it's clear. So on that same topic, let me give you some recommendations around how to manage and how to deal with a vendor provider and how to consider on some design considerations when it comes to dealing with this. So number one, do not store a vendor provider appliance on a virtual volume data store, on a vVol array, on a vVol container vSphere data store, because if there's a problem with it, you know what's going to happen, right? If you can access it, now we have an outage, we can do it. Recommended to put it on either a VMFS system, or if you just so happen to have the greatest thing ever created in the world, which is called Virtual SEN, put it there, right? It'll work just fine. And give it all the availability that you want. Obviously, not only do we leverage that kind of capability, but the VASA provider itself has what we call a high availability framework, which allows you to have active, passive vendor provider configurations, active, as well as, in the event something fails, you can have multiple registers in different places. But again, depends entirely on the implementation and some of the limitations driven by the vendors.
All right, I got a question here about those. When are those bindings done? So how often does it ping for the VP? How often does it ping those for the storage capabilities?
Seconds. I mean, less than, it's quick, always, right? So there's a matter of so a bound operation, a vVol, is considered to be active or passive. And actually, let me show you. That's a great question. Let me show you exactly what we mean by that here, because there was a screenshot. So if you look at the right-hand side here, notice how we have these bound status on the right-hand side over here on the screen. I hope everyone can see it. Those are active, right? Those are we're bound, we're active, we're talking. Whereas, for example, a snapshot is unbound because it's not active. So when will it be bound? When the snapshot is activated, to the sense like, let me access, let me kind of enable, and then it gets activated in that case. So that there is a process in time that happens to either sustain or maintain the bound and the activity of a particular object in that case, which is very important because I'll show you here. Hopefully, I have a slide here. When do these binding operations happen, and how do they take place? Right, which is a really good and important thing to sort of discuss there. So there's a lot of focus on the vendor provider. Just a little bit when it comes to when it's managed as a virtual appliance. There's a lot of different things in it. So when you think about it as a single point of failure, not everyone implements the high availability feature of the framework, but they leverage HA, which then, if you think about the integration capabilities and how this whole thing is addressed from a software perspective, not only can you leverage other solutions that are part of the platform, but the solution itself has its own availability sort of capabilities. But then if you have this on an array implementation, how often does your controllers fail, right? On an array, they happen, right? But when they do, I'm sure a vendor has multiple controllers, and in that case, that sort of thing is sort of managed, which is kind of like the same way we would do it in the software implementation of it, right? One of the things that you don't have to deal with is that at least if it's a storage-based implementation, there is one less appliance you have to worry about dealing in terms of managing it and dealing with. But it's not something that it's going to do more than just you just need to make sure it's always active, because that's whenever you are executing, provisioning, and doing things, that's where those calls are happening through, right? But once they're bound and things are communicating, the protocol endpoint is able to manage those kind of things. Any more questions there?
Okay, we've got one more question, and I may have to
Uh-huh.
be really mean to everybody and call it shortly because I have other responsibilities. But I think it might be a decent place to stop it because next week we're going to talk about vSAN, which this kind of talks about anyway in
Mm-hmm.
terms of the policy management. So one question that we've got here is how about SRM? Is there support for vVols on vendor developed SRAs?
Who asked that question? I want some names.
Brian Welch.
Man, Brian, you're going to be responsible if I get fired tomorrow. But I'm going to answer this question. So, so obviously there are some limitations today in virtual volumes, which is in the data services that are supported. One of those data services, even though which is why I apologized before in the previous slide when I showed you the capability was replication here, right? Because replication, array-based replication, is not supported with this initial release of virtual volumes. The reason for that is I don't want to get into it because I don't want to hang myself a little deeper, but the concept of virtual volumes is to bring these storage capabilities and expose them through our framework, through SPVM, which then they can be consumed as a VM storage policy. So that's the replication aspect of that. An array can totally do array-based replication on its own, right? That is what we call an unmanaged sort of a feature, because the reference to unmanaged is because you can manage that from within the vSphere UI, from within the framework of virtual volumes, individually per object per VM. It is something that's managed entirely at the array level, right? So there's some things we got to kind of some guardrails we got to walk through there. In reference to SRM, SRM today does not work with virtual volumes from a array-based replication standpoint because the SRA that exists today do not talk or know how to talk to the VASA provider, the vendor VASA provider, which is that is how everything works, right, within virtual volumes. That vendor provider is key because all communication goes through them. Now, that can change, in the future or whatnot, but for lack of a better term, if you're interested in having replication, you can use vSphere replication, which is fully supported, and it delivers a per object per VM type of replication capability if you wanted to do that. Now, we all know that vSphere replication at one point was a part of the SRM architecture, and then they were decoupled. Can you use SRM and vSphere replication? There are some things that are short, but that is a solution that today is not supported. So I can tell you that you will have to probably utilize some of your fancy scripting, which is not too difficult, some orchestrating, to kind of do what we do, bring VMs back and forth, up and up. Now I can say that today, as of this moment, and obviously things can change in the future, but depending on how things go, VMware's decisions, not mine, product managers, and the vendors, that could be fixed at some point in time. But as of today, right now, SRM does not work for vSphere virtual volumes because we today don't support array-based replications for the reasons that I listed. And I hope that maybe answered your question.
It does. That answers the question. All right. So everybody's asking me not to cut you off, but I really do have to go, unfortunately. So what I'm going to do is I'm going to steal the presentation back off you.
What?
Yeah. I'm sorry. What I'm going to do is I'm going to ask you to come back next week and potentially, instead of doing virtual SAN next week, how about, has my screen come up yet?
No, I don't see it. I see my own deck over here. Hold on. I see your deck now.
All right. So next week we were meant to do vSAN. What I'm thinking is...
Can't skip that. Are you kidding me?
Sorry? See, this is the conundrum, right? what I'm thinking is, so that we've got enough time to finish virtual volumes, let's do that next week.
Mhm.
Then Mike and
Okay.
Josh can come and do their security and automation, and then I'll have to talk to Jonathan, but maybe we'll push vSAN off to another week, because I know that you're going to talk for just as long, if not more, about vSAN than virtual volumes.
Absolutely.
But we're not going to skip content. I just want to make sure that everybody's happy with the scheduling. But that's what we've got at the moment.
How about I'll offer Mike $20? We skip him. We'll bump him down.
Bump Mike out.
Security, for crying out loud. Come on, Mike.
Yeah, well, we'll see what happens. Anyway, I have to call it now. We've been going for an hour and a half, so hopefully that's enough for people to get their heads around this week. And then next week, you and I will be back, and we'll talk about vVol some more, or we'll talk about vSAN. We'll work it out, and we'll come back again after that to finish off whatever we haven't covered, regardless of what the order's in.
I love it. This was awesome.
Awesome. Thank you, Rolson. I really appreciate you coming on, and I hope you don't mind the Stig references earlier. It's all good. Thanks, everybody, for listening, and we'll see you all again next week.